Welcome to the second December 2025 meeting of the Garden State Java User Group. It's a bit of a cold day here today, but so thanks for coming out. Let's go with our normal agenda here. We want to thank our sponsors as we always do. Talk about what's new, but since last week there really hasn't been much, I'll try to remember what was happening. Our gold sponsor is Payara, and they're the makers of Payara platform, which includes Payara Server, Payara Micro, and they also have a new offering called Payara Cube, which includes their cloud service. There's a 15-day trial for that. You can try that out. It works very nice. I have a demo account, and I was able to showcase that a little bit last week at the webinar that I delivered. Azul is our silver sponsor, and they're the makers of Azul Zulu, which is the downstream distribution of OpenJDK. DevNexus is our partner, and this is the conference that's held in Atlanta every spring. Chandra and Barry will be speaking at that coming up in March, and I'll probably go as an attendee this year. There's the Java Champion Summit and the Java User Group Leader Summit as well on the first day. Our per meeting sponsors are Romanelli's provided the pizza tonight, so folks, please eat up. We have soft drinks, of course. JetBrains provides the licenses for us to raffle off each month. Jakarta EE and the Eclipse Foundation provide hosting via Crowdcast. All right. Our memberships, as you know, are Jakarta EE Working Group, the Microprofile Working Group. We are guest members. We were contributing members with Microprofile at one time, and then we're also members of the Jakarta EE Ambassadors. Let's see what else we got here. Yep. Okay. Let's see. So what's new? We're getting closer and closer to getting things organized for the 25th anniversary celebration in February. We chose a date of February 17th. We may have it in person, even though we have February 10th all set. So stay tuned. There's some things happening in the background for that. All right. JDK 26 is now formally in ramp down phase 1, and this means that the 10 features that have been committed to it are now frozen. There can't be any additions, there can't be any withdrawals, although that happened once under some certain circumstances. And ultimately that JEP got added in a couple of releases later. So it does happen. So the ramp down phase 2 will be in mid-January, and you can see all the way down to March 17th. There was also the JDK 27 expert group was formed, and this is a pattern I've noticed, so I always look for it. The day of ramp down phase 1, they announced the expert group for the next JDK release, which will be in September of next year. So then you'll start the normal build process. Builds 0 and 1 were released. 2 will probably be out on Thursday. That's when all the releases, incremental releases, are provided. Not much has happened in Jakarta EE. As you know, you have the new specs, and so Jakarta Query 1 is actually part of the platform for Jakarta EE 12. And the others that you see there will most likely not be part of 12 only because of the work, and they're relatively new. There was a lot of work done already on Query, and I can tell you more about Query. Maybe we'll have Otavio Santana talk to you about Jakarta Query. Also, there's supposed to be a milestone 2 release. That didn't happen. A lot of the specs did not provide a milestone 2 release. So we're going to try for mid-January or end of January for that. All right. So look at that. I did not edit that properly, Rogério. I'm sorry. It's
Not
always
Eric.
I've
No.
Eric was our speaker last week, and I updated the slides, and copy and paste is evil. So let me let me read your bio from. Let's see. I'll have to do that. Actually, I'll do that here on the laptop, the one that's not working. Uh, okay, just give me 1 second here. Okay. All right. So, Rogério Robetti, live from Dublin. I think I mentioned that already. We already talked about tea, so that's a good thing. Is a lead software engineer with over 18 years experience building and leading engineering teams in the financial and technology sectors. Based in Dublin, Ruggiero has contributed to the success of organizations like Mastercard, Bank of America, and Huawei. I think that's how you pronounce that. And is recognized advocate for modern software architecture and best practices in Java development. He's a published author, holds several industry certification, and is passionate about mentoring and innovation. In 2025, Ruggiero founded the J Proxy project, which is what he'll be presenting to us tonight. I think it was back in September, right? You presented this to the Dublin Jug, and
Yes.
then I was asked to. Oh, I guess I offered or whatever, but uh, I followed you with my Jakarta EE11 and 12 talk. So that was fun meeting all of you. Apologize for all the technical difficulties we've had here. But with that, I'm going to change it over to you and, for your presentation.
Thank you, Mike, and thanks for organizing this. I really appreciate the work you guys put in. It's a pleasure to be here, to join you today, and to present the J Proxy to your public there. Just to make sure my audio is okay. Can you hear me all right?
Yes, I can hear you. How about you guys in the back? Can you? A little bit, yeah. So let me move my phone over a little more as I can. Um, just so you know, we don't have Barry here with us tonight, so we don't have our usual AV setup. So yeah, okay.
Yeah, I have a little presentation here. Let me get it up, and just let me know if you can see it in the screen there.
Yep, looks.
All right, so starting off, this is a presentation about J Proxy, right? Let me.
It's rotate. Oh, rotate. Oh, there we go. Thank you.
Is that okay there?
Yep, yeah. I was just orienting my phone so that we have a full screen instead of a partial screen.
Yeah. So this is our agenda for today. Not gonna spend much time here. We're gonna go through the agenda. This is a legal notice in relation to this presentation and in any materials presented here today. They're free to use. I'm just not responsible on how people use it. That's all this is about. I've been introduced already, so no need for that. I have my own partners I'd like to mention as well. Comunidade Brasil Jug is a community that has supported the project from the beginning. Switcher API is a feature flag open source project that the people from there, the developers, have helped OJP as well a lot. Meterion is from Java champion Bruno Bessola from Italy, and is a very nice scanning mechanism for finding issues in open source software. CyberJar and Java Challengers are YouTube channels. CyberJar more on the side of content creation, very crispy, nice quality, perfect quality, I should say, content. They're quite a new channel in the Java space. If you don't follow them, you should. Probably should. And Java Challenger is from Rafael Del Nero, another Java champion. So he's more focused on career development. So if you're looking to develop your career, there is the place for you to look for a free meeting. If you get the link from our main page, you can get a free evaluation with Rafael. So starting off, the more technical thing is we need to to get started with a fundamental concept here, and that is serialization usually, or most of the time, beats parallelization. And we just need to remind ourselves, because we get into all these abstractions in software engineering, and sometimes we forget how these things work at lower level, right? And at very lower level, we have a limited capacity of CPUs, for example, right? Which is limits our capacity of parallelization. And what that means in short is, if you put too many threads in a CPU that has, let's make a simple example, eight cores, and you're putting 100 threads against 8 cores, that will perform slower than if you had less threads and you serialized the request against it. I'm just making an example, but the reason for that is that when you have too much parallelism, what the CPU or any system needs to do is to basically save state of one thread, load the state of another thread, and then execute. And this juggling of threads consumes time, consumes effort, time and effort that could be used otherwise processing requests or doing some useful work, right? Having that in mind, this is very important because it's a fundamental concept that drove the creation of OJP, and I'll explain more on following. So let's get an example going. Let's say we have our Spring Boot application, which is, I think, pretty much the most common example we can make with our 10 connections. Very simple example here, connecting directly to your database there. The database is happy, no trouble there to handle 10 connections, right? And connections, just understand that we use here connections as a mean of how much parallelism you're allowing to the database, right? Because obviously, just having open connections doesn't mean you're putting pressure in the database. What matters is how much flow is going through those connections. But let's assume here that you have busy connections, all right? Let's say there is a day that you start having an increase on demand, and that demand start creating, you have a elastic scale configure cluster of your Spring Boot application that starts scaling out as you configured it to do. At some point, you have already 3 instances of the same app, and now you have 30 connections, right? For our simple example here. The database is starting to get you worried there because, suddenly from 10 to 30, 3 times the number of connections. It might be a Black Friday or some celebrity posted about your product, and you're getting a lot more requests than you usually do, right? And that load increases. We are now to 5 instances of the same app, 50 connections. And when it reaches indexes, simple example, 8 instances, we have our database belly up, right? That's a scenario that can happen. It can happen in scenarios like the one I described, where you have a legit increase on demand, or it can happen as well on a DOS attack, right? So if you have a denial of service attack happening against you, this also could happen. You have an increase on demand that is unexpected, unplanned. And most of the time we plan our systems for averages and what we think will be the most busy days, right? And the database is hard to scale. As you know, even in clouds where there are offerings of elastic scaling databases, that's not as simple as it looks, because to auto-scale a stateful system, you need to move data, right? So what clouds usually do, they have a pre-heated node that you're always paying for. So so if you use the elastic scaling capabilities of cloud, there is no magic, right? Like to start a new stateful node, they need to preheat it, and you're paying for that. So the core aspect I want to make clear with this part is easy to auto-scale the application side, because we produce these applications that are mostly stateless or fully stateless. We've been doing this for many years. We know how to do that. We do it very well, right? We have tools to do that, and we can scale out our apps quite easily. With stateful systems like the database, that's not as easy. And the database usually remains with a limited capacity. What we usually do to compensate that is that we operate with a bloated database, right? We operate with more capacity than we really need, and that incurs in costs, right? Like I think most of the big companies, like you have everything duplicated, you have massive servers that can take 10 times the load, the max load you actually expect for the application. But that incurs in licenses if you're using something that's paid, or in costs of hardware, servers, etc. So which questions OJP aims to answer? Like having put that out there, like as a dissonance, right, of these microservices and Lambda's world, where we can auto-scale our applications, but the database and other stateful systems are not as easy to auto-scale. So how can we auto-scale our apps without overwhelming the database? That's the first question OJP aim to answer. How can we make it compatible with different database and available in different environments, and make it more agnostic than available solutions like AWS proxy or PG bouncer. AWS proxy is a proxy like OJP, but it only works in AWS. PG bouncer is also a proxy for database, but it's only for Postgres, right? So how can we make something that works everywhere? How to deliver seamless integration with Java apps? That's an important question. How to make it more open source than existing solutions, because we do have plenty of solutions for database proxy. Not all are open source, some are partially open source. So can we make it fully open source? Can it be developed in Java? Because we are Java developers, right? It is a Java user group. So if it's developed in Java, we understand it better and we trust Java, right? And can we have a connection pool as efficient as Hikari CP? Why Hikari CP? Hikari CP has been shown to be one of the best, if not the best connection pools available. It's the full connection pool of Spring Boot, not for no reason. And the question arose, like, can we have a connection pool as efficient as Hikari CP? And then OJP solution came about. If there's any questions, guys, you can interrupt me, okay? I know I speak a lot, but if you have any questions, anything you need clarification, you can interrupt me there. And Mike, can you hear me there? Can you just say something if you're hearing there?
Yes, I can. I can definitely relay the questions to you.
Good. Just to make sure I have the sound back. Perfect. So this is the high-level design of J Proxy. Basically, what we did here is we externalized the connection pool to a separate application, a separate server, right? And we leveraged a gRPC protocol and the gRPC server technology. So it's OJP server is basically a gRPC server, right? So it leverages the protocol. It sits on top of HTTP 2.0, so it gets all the multiplexing capabilities that the HTTP 2.0 brings to the table. Make it very efficient to communicate with its own JDBC driver. That's the other part on the left there that sits with the Java app. So OJP is separated in two parts. We have an OJP proxy server that sits outside of the app. It needs to be deployed. It's an individual piece of technology. And it runs Hikari CP. So to answer the question, can we have a connection pool as good as Hikari CP? If you're writing it in Java, it is written in Java. Why not to use Hikari CP? So the full connection pool is Hikari CP, and we get all the goodies of Hikari CP right away. So what this produces in this image is by controlling the JDBC driver, so we have a JDBC type 3 driver, which is the first open source JDBC type 3 driver in the world, as far as I know. And we have a proxy server, a layer server proxy server, which gives us the ability of doing very interesting stuff on the OJP proxy server. But the most basic gain we provide is this abstraction of connections, right? So in the image, you can see that each app has 10 connections open to each database and multiple different databases, right? So Oracle, MySQL, and Postgres in this example. But the real connection pool inside OJP server only opens a limited amount of connections. And that creates an intrinsic back pressure, right? So in our example there, that we had a growing app, that growing app will not increase pressure in the database, because the database will only have the number of connections configured in the pool that is managed by the OJP server. And that's the first gain we give. Another thing is that our solution is fully open source, right? Apache 2.0, so no restraints there. You can use it as you wish. And we support multiple databases, because basically we embraced JDBC. So because JDBC is a battle-tested technology, it's been here for a long time now, and it's every relational database that is out there supports JDBC interface, right? So because we sit on top of these three technologies, basically like HiCP, gRPC, and JDBC, we can take the advantage of being able to support multiple databases. And if we go back to our example with 8 instances of our application, that would not produce 80 connections against the database. In our example here, we could cap that at 20 connections, and that would be the maximum number of connections. What OJP will do, it will coordinate how these connections are used, and it has a clever way to do it. For example, it never enlists a connection when a connection is asked. So let's say your application asks for a connection, it's preparing its parameters there, creating your prepared statement, adding parameters, doing some calculation, whatever it needs to do before it executes an actual statement to the database. OJP never enlists a connection at that stage. It only enlists a connection when it's ready to execute the statements. So that small amount of time it saves at scale becomes big amount of time, right? If you ever worked at real scale, you're gonna understand it right away. Every nanosecond you save, it's important. If you can save a millisecond, that's hugely important. So that's what we do here. We don't enlist connections unless they are ready to go, ready to execute. That's one of the main, or the first things we did in OJP. And that's how it serialized more the execution than parallelizing. And if you did tuning for the database, like oftentimes in many instances, when you reduce the amount of connections you have with the database, you gain performance, right? Of course, you need to do your performance testing. You have to have good parameters for that test of your real workloads in production, but it's not uncommon to see situations where by reducing the total number of connections to the database, you actually gain performance, right? One other thing we notice is that OJP sits very well with architectures that we call distributed monoliths. And before people turn their eyes around, something came out of research we did inside the groups that and the meetings we have at the OJP. And it is a very common situation where companies migrate to microservices, right? And they split up all their services into business-bounded context services like orders, billing, inventory, whatever. But their database remains a single point of contact, right? A single point of failure. And that's mainly due to the cost of doing the separation and having multiple instances of the database running, and due to the complexity of doing it, right? And sometimes you have teams that are not used to managing multiple instances, like there's licensing problems. Many different issues were cited, but it's a very common situation that companies end up with the microservices divided on the application side, but the database remains a single cluster, and shared among many or all the microservices. If you're lucky with different schemas, sometimes not even that. OJP sits nicely with that because it creates a shield to the database, right? So if we are talking about shielding the database from pressure, if one microservice can put a database under pressure, you can just imagine if you have all your microservices pointing to the very same database. So putting a back pressure mechanism in front of the database seems a very reasonable thing to do, and OJP is that back pressure mechanism. A quick comparison to other proxies. What we compared in this diagram here is like open sourceness and versus the database agnosticism. And we did that in purpose, obviously, to show how important it is to have something like OJP in the market. Because you see that other proxies that existed, either they were not open source, the red and the square dotted ones. The square dotted ones are hybrid. They have parts that are open source. And the blue ones are open source, right? But then if you're down on the vertical axis, it means you don't support a lot of database, like PG Bouncer, for example, or PG Pool, only Postgres, right? Then you have Atlas, Vitess, PostgreSQL, and MaxScale, or ProxySQL and MaxScale that supports more database, but nothing like OJP, because, for example, the ProxySQL there, it supports the MySQL family, right? MySQL, MariaDB, and Postgres. That's about it. And it scores higher because it supports multiple databases. But OJP can support many others. Like we have tests for Oracle, DB2, SQL Server, CockroachDB, Postgres, obviously, MySQL, MariaDB, and H2. So like these are databases that we have tests that run with every commit we do to our GitHub. So, and like there is no really limits, right? Because as we obey by the JDBC standard, we can add any database that respects the JDBC protocol. All right. This is just a description of what we just talked about. Let me see if I missed something here. Like we are cloud agnostic as well. You can deploy OJP in any cloud. One cool thing about using gRPC is that makes us not only Java compatible, right? Like there is nothing preventing someone from Python or C# from creating a client to OJP server, because as we created an API in protobuffers and we compiled this in Java to make our JDBC driver client, you could create an ADO.NET client for OJP server. We have friction and integration with Java apps because we provide a JDBC driver, so you just need to drop that driver into your application. And we are bringing to the table unprecedented freedom to the proxy landscape. I think that became clear with the previous slides. There is just an example here, right? You can compile to multiple languages just to exemplify. And going forward, one of the first things we noticed when we were doing some initial tests with OJP was that if you have a query that is constantly fail, you lose a lot of performance, right? So let's say something was idealized to never deal with zeros, right? And eventually one day there is a zero in the table, right? Not that uncommon scenario that you have something that was projected to have to deal with a number of parameters and somehow a parameter that was unexpected show up. And that query will fail constantly, right? That's one scenario for repeatedly failing queries. Also, when you're under stress, when the database is under stress, a common failure that starts to happen is timeouts, right? So the longer queries start timeout all the time. So it became clear to us that it was important to develop a circuit breaker in the OJP infrastructure, in the OJP server more specifically, so that these queries that start failing consecutively, they get stopped from sending them to the database. So we stopped sending them to the database, creating a breathe room for the database. In the case of the database being under pressure and timing out queries, that creates that little bit of space for the database to breathe and maybe to come back to life instead of falling apart. And in the case of queries that always fail anyway, why to be sending them to the database, right? So we save database work basically. So this is just a general explanation of a circuit breaker, right? How it works in OJP, but it's the general concept of a circuit breaker. So the query is failing repeatedly. OJP will identify that this query is constantly failing. By default, 3 times is a single. If a single query fails 3 times, it will be blocked by OJP server. And for a minute of interval, all that is configurable. Okay, if you need other values, you can change. For a minute, that query will not be sent to the database. And then after that timeout, you're going to send one query to the database. And if that query is good, you're back to sending it to the database. If it's not good, you block it again and wait another window, right? And that creates a little bit of help to the database in relation to not receiving queries that are constantly failing for different reasons, right? Moving forward, how does it perform, right? So in relation to these performance tests, I'll actually pull up the latest figures we have. There are 2 articles in relation to performance. I'll just show you one of them. One of them is this one. And what we did in this was we throwed 100 threads, right, with 67 queries in each in a preloaded database. So it's a shop service app, basically, database. So you have your orders, you have this kind of information in the database, and there are thousands of records. So we used very small DigitalOcean droplets to do this, so it would be easier to stress it. And then we compared OJP versus direct JDBC connections, right? And the results are these for the first tests. So the total queries executed were 6,700. The ramp-up program was 1 minute. So with OJP, the full test finished in 64 seconds. Without OJP, it took 80 seconds to finish. And the average query duration, you can see that it dropped a lot. And because of the reasons we spoke so far, there was a query failing put in purpose in this load, so it would activate the circuit breaker. One of the things we want to test with this test was the circuit breaker as well, and avoiding the parallelization, right? The excessive parallelization. Query failures 100 because there is 100 thread. One thread is poison, right? Like we put it there in purpose. So the important bit here is that the OJP doesn't fail more queries than without OJP, right? That's the takeout. And CPU, we were very focused on looking how CPU behaved during those tests. So with OJP, the max CPU on the database was nearly 15%. Without OJP was 61%. And that comes to tell, like, if you don't avoid that excessive parallelization, the database is doing a lot of work to handle the threads, right? To switch context between different workloads. It takes longer to manage locking mechanisms because it has more concurrent threads trying to lock things at the same time, right? So basically, it wastes time and resources doing things that are not the job you want the database to do, which is inserts, updates, deletes, etc. It spends its resources organizing things, which is not its job. The average CPU remained quite stable at 10.23%. I mean, average, it didn't remain at that. It obviously peaked at 14%. And the average CPU for not using OJP was 41%. We had a second article published in relation to performance, which is the same test, and we did it for different numbers of threads then. Instead of just 100 threads, we basically started with 1 thread and went on continue to increase that by 25 threads at the time. So what that produced was Let me just see here if I can find the article here real quick, and I can show you the numbers. Yeah, this is the follow-up performance test. So it's the same test as before. It's just that we created a range of threads, right? And I think there is one one extra query here that was not before. So I'm not going to go through all the details of the test. I just want to show you like what are the results. I think that's what matters for the presentation. So you can see here the number of threads from 1 to 200. And we started this test by just increasing without OJP, right? Just increasing until we broke. Basically, we just kept increasing threads until we could see failures in the database. So without OJP and any other connection pool, at 150 threads, we started seeing failures, right? So to execute 150 threads, so that's 10,200 statements, there was 229 failures. And those failures just increase. The times just increase almost exponentially, or at least in a linear fashion here. And with OJP, I think the most impressive thing to me during this test was how stable it is throughout all the increased load. If you can see here, like it remains impressively stable throughout all the load. And also for a single thread, right? One thread is 68 statements, right? So it's not a single statement. We don't test single statements. We understand that a single statement will take longer to go through a proxy, right? But we see no purpose doing that. Like no application sends single statements to the database, right? At least no application that worth putting the time to design and to think about a proxy. If you're small enough that you only send single statements to the database, then there is no need for all this engineering, right? This is for larger loads. But the interesting fact here is that one thread with 68 statements with OJP took less time than without it. And that was very surprising to me because I thought, okay, we're going to win at load, right? At 200 threads or 100 threads. We already knew we won at 100 threads from the previous test. But at one thread, it was quite surprising that we were already faster than not using OJP with a single thread. So those are the early performance results we have. They're very encouraging. We're very happy with them. I think it needs more testing. We are encouraging people to do their own tests, to bring this to their companies, to put in real workloads and bring back the results. But the initial results we have here are very encouraging. Like we're very excited about them, and we're very excited to see the results in real scenarios. Now, if there is no questions there, I've prepared a quick demo. Let me just go to my shop service here. So this is a Spring Boot application. Okay, so it's basically connecting to H2 in-memory database using HIC-RCP standard, the connection pool that comes with the application. I increased the size of the letters here. Is that readable for everyone there? Can you read all right? Are you still there, Mike?
Yes. Can you hear me?
Yeah, I hear you, yeah. So is that okay to read?
Oh, I'm sorry, yeah. Okay, everybody's saying yes. Okay,
so moving forward, this application you can find in our GitHub. There is we have a repo called Java Framework Integration. So we have a few applications there. Is always the shop cart application, which is a common scenario, right? Like orders, customers' orders, reviews. And we have the same application implemented in Spring Boot, Micronaut, and Quarkus. So you can see the same application implemented in multiple frameworks. we run these integration tests every time we commit as well. So every time we commit, we test with a few frameworks, a few Java frameworks, popular ones. And this is one of the ones. So I'm just reusing for the test here. For this test, I removed OJP, right? So I can show you how to introduce OJP on a Spring Boot application that doesn't have it yet. So what's happening here, like we have our user controller integration tests. They are passing at the moment. We're just going to run them once again here. Make sure that they're still passing since before we started the presentation. They're good to go. And now we're going to use our documentation here. This is our GitHub page, right? So from the very first page here, we can see the steps for a quick start with OJP. The easiest way to run the server, right, is to run our Docker image. So that's what we're going to do here. We just going to get the a Docker container with a OJP server. That is something. Let me just see if that's healthy. Docker. Yes. No, it didn't start up. That might be because I have one running here. Yeah, that's the reason. So it's a port conflict. I had a test running there before. Let's just start it again. Yeah, now we have an OJP server ready to go here. Version 020 beta. The version 030 beta is on the way. It should be released on next Sunday. So that's what we are planning to do. And that will bring cluster capabilities to OJP. So that's something nice to look forward to. So we'll be able to deploy multiple OJP servers. There will be load balancing, failover. All these capabilities are coming up as well. So we have our OJP server running here. Now let's see what's the next step here. We need to add our driver, right? So we need to, yep, I hear something there. Any question?
No. That was me saying, oh, cool.
It is cool indeed. I agree with that. Yeah, let's put our dependency here, right? So we need the JDBC driver that OJP provides, so you can connect to the OJP server we just started. And let's see what's the next step. Next step is to change our URL connection, right? So to make it easier for Java applications, we created this prefix pattern that allows you to not have to configure a bunch of different things and to be able to use OJP. So with this third step, you should be able to use OJP already. I'm going to go a step forward and show you as well how you can use named data sources, but that's not required. Like if you have only one data source, there is 4 steps really to get it started. So what we're going to do here is we're going to put this prefix in our connection URL. Let me just get a example because we are running with the full port, which is 1059. And that goes into our application properties. In this case, I'll put in the application test properties because we are running the integration test, right? So the scope is testing for this demo purposes. So it's always just after the JDBC colon. So you add this prefix, and that's it. You should be good to go. Now, the driver is different, of course. Like if we were using H2 before, now we're going to use our J Proxy driver. And here also, we're going to be using our prefix for OJP, right? So that's done there. Because we have 2 data sources here, we're going to have an extra bit of configuration, right? Because as we have 2 data sources, we need to create what we call an OJP properties. And that goes into your resources folder or the root folder. It looks in both places. And I left it ready here to go, like the contents of this, and I'll explain what they are. It's just connection pool configuration, right? So if you don't put this, it's going to use the default connection pool configurations of HIC-RCP, which, if I'm not mistaken, is 10 max connections and 2 minimum, something like that. But we are setting here the settings. This is the default connection pool configurations will look like this. They will going to start with OJP connection pool, and then what you're setting, right? Maximum pool, minimum idle, connection timeout in this case. And when you have a different data source, the only difference is that you name it at the beginning, right? So in this case, we want to show that we can do a high performance data source, which basically has more connections than the full one. So if we have a named data source, we need to put that name into the configuration here. So, and the way to do that is just in brackets you put the name there. So now we have everything configured now. Like, let's just refresh the Maven dependencies, make sure that we get what happened there. Did I put it in the wrong place? Looks like it. Let me see what this. Just make sure. Maybe I broke this POM XML. Let me quickly try to troubleshoot it. And I think there is an easy way to fix it. Let's just roll back to the original. And in this scenario here, it should be good. One extra step that I didn't talk about, but it is necessary, is that we need to exclude HIC-RCP from the app, right? As we are delegating the connection pool capabilities or work to OJP server, we cannot let a connection pool in the application side anymore, because they basically start stepping on each other's feet. Like, there is no way to have two connection pools working in both sides. We even tried at some point to try to coordinate. It's close to impossible, because you can have only one source of truth in relation to managing the connections. So if you're using OJP, you don't need a connection pool in your app anymore. That's actually easier, right? You can treat your app as that's very good for lambdas, right? Lambdas cannot, lambdas and serverless applications cannot have connection pools anyway. So it's a very useful part of it. Okay, so here, those are the changes you need to do to use OJP. So what's left for us to do now is to run the test again, and we should see it passing, right? So that's the indication that what we did here worked. Let's just build the project again. Let me put this down here and run the project again. And let's just wait for the result. Oh, we have a failure. Let's see what happened. Think couldn't find the dialect for the URL. I think that's a problem with the dependencies. Let me just reload this. And actually rebuild it entirely. because it should get let's just double check. We set the right driver that should understand this new URL that we changed. And let me just make sure I set it in both. Yeah, the dialect is H2 dialect. I don't think that's the problem. I think the message is a bit misleading. Oh, that is interesting. And that is awkward. And quickly see what is different here. Like, oh yeah, okay. I forgot one detail there. Okay. So yeah, basically if you turn off, yeah, that my bad. I should have read the documentation. Usually in these presentations, I go to there is extra documentation here, which I should have followed. So to integrate Java frameworks, you can come here to Java frameworks and Spring Boot. In Spring Boot, when you disable the Hikari CP, you need to put something in place, right? Because you need to tell Spring Boot how to create connections. And you can use this simple driver data source to do that. So that's the guy who's going to create the connections now. And I forgot to do that. So let's just run it again with it back. Oh my God. Yeah, that there is something I'm missing here now, which is surprising, to be honest. And let me just see what else is. If I missed, okay, this is not relevant. I'll just put it back. But this is the application properties. We are doing tests, so only test is relevant for this. Oh, there was one more here. I missed. The same thing. You need that data source for both. We have two data sources. I put back only for one. Probably that's why it didn't work. And let's just quickly check what. There's nothing relevant here. It's unable to. This is a bit weird because there's nothing visibly wrong here. This usually works, and it's a little bit embarrassing that they didn't work this time. It's the demo kind of. We just do one more rebuild here, and if it doesn't work, I'll have to continue with the presentation just to not take too much of time here, and I'll come back to you on what happened to this. So let me just see Docker logs for this. Just see if some failure here in the server. I don't think so. It's just a configuration in this.
Yeah, I was going to say, you wrote DOKER.
What is it?
You had DOKER in your last command.
Yeah.
Yeah.
Thank you. Yeah, there is no errors in the Docker. Okay. Let's try once more. Yeah, what was And this should not be the problem. And that's very awkward. Like, it looks like it's a cache problem. Like it might be an IntelliJ cache problem because it's telling that the dialect is not recognized, but we put the driver there, so it should recognize it. So final attempt, I promise. If this, while it restarts, I'll continue with the presentation a bit further, and we'll come back to IntelliJ and do one more trial. But this never took this long. It's 4 steps, right? Like it might be just because I've been switching between the driver before the presentation. Now, like I think IntelliJ might have the cache dirty at this point. So let it reindex everything there, and we'll come back to that in a second. That's our demo. Failed so far. Hopefully, it's just a cache, and that would be that. So yeah, we have documentation for Spring, Micronaut, and Quarkus, right? As I spoke before. Another cool thing we developed for OJP is this low query segregation, right? So we understood that as we decrease the number of connections for a connection pool, it arises a risk of slow queries taking over the pool, right? And the best way to explain this is comparing this to a highway. So in a highway, if you have too many tractors or trucks and they can run in any lane, they can clog the highway quite easily, right? So for OJP, what we did, we basically separated the lanes into 2 sections. So we have a slow lane section, or a slow slots section, and a fast queries, fast slot section of the pool. By default, it starts with 80-20. So 80% of the pool is for fast queries and 20 for slow queries. That's pretty much a bulkhead pattern, but it's not just a bulkhead pattern. What we do, we develop a cheap method of measuring the average response query for all these queries being executed against the database. And then we do a simple calculation to allocate the queries into these low lanes or the fast lanes, right? And that is how we prevent the pool from being overtaken by slow queries. So that's something that no proxy has at the moment, and I think is very novel in the field. Let me just see if I have our app back here, and if we can attempt to run this test again. And if it runs, well, let's see. Just give it a shot. It's not cache, and I really apologize for this. Like I did the same. It's just this message. It doesn't seem to make much sense to me. It's weird how let's just revert them all. Anyway, I'll have to investigate it further, and apologies for that. It never happened this in presentations. There is always a first time, right? I gave this presentation, I think, already in 5 or 6 Java user groups. It was always easy to showcase this, but there is always a hard day, as it was hard to connect there at your end. I think today is a hard day for everybody.
Yeah.
Anyway, I promise you, it's not that hard. It should work right away. I might be missing something. I don't think I am at this point, but like Mike said, it's very late at Dublin. Might just be me a bit sleepy and doing a presentation. Anyway, guys, this pretty much wraps up what I had prepared. So the links to the Git rep are here. If you can scan the QR code and leave us a star in the GitHub there, that would help us a lot. Because it projects the project, it helps the project gain momentum. What we ask from people is to try by yourself, right? Don't trust that this is hard as in this presentation. It's not. It's very easy to get started. And you can deploy it on non-critical applications, even though it's a beta version. It's a very well-tested version. We're very confident that it can tolerate good amount of loads or even very heavy amount of loads. You saw the test we did. We tried to break it, and it's showing very promising results. You can contribute code. Obviously, it's an open source project. You can produce content about the project if you want, and to share it with your networks. Here are the links, right? We have our Discord. You can buy us a coffee. There's a button in our GitHub page. That's my X account there. And one last cool thing I'd like to show is this contributor recognition program. This is something that we developed so people that help with the project can get rewards. The rewards are the badges, and you progress in the community until you become an OJP champion, right? So there is 4 lanes for contributions. Code is the blue lane, testing and quality is the green lane, evangelism and community is the purple lane, and documentation and content is the orange lane. So you can contribute in many ways. We developed this as a way to reward people that don't contribute code. Like if you write an article, if you share constantly our contents with your networks, and you help to spread, or you give a presentation like the one I'm giving today, you get these badges, right? And you can share them in your LinkedIn. If you click them here, they go straight to your LinkedIn, and they appear there as in your license or certification section, right? So that's it, guys. If you didn't ask yet and you have any questions, any comments, now it's the moment. Thank you very much.
We have one question here. First of all, let's thank Rogério. So yeah, one question so far.
I have 2 questions. The first one is like, it's really cool to see the request segregation, right? So the slow one versus fast one. But how do you estimate if one is going to be fast or slow before running it? Like, how do you?
That's an interesting question.
Which lane to go?
Very good question. Yeah. We don't know in the beginning, right? So we are an adaptative, so there is the cost of learning, right? But what we do is once we have one measurement of the query, we can already put it in a category, right? So it's everything is fast until proven slow. That's basically what we do. So everything goes to the fast lanes in the first execution. But there is a warm-up period, but it's pretty fast. As soon as each query run once, we have a measurement, and that measurement allows us already to classify that query into slow or fast. So at the beginning, we don't know. That's the answer, right? So everything is fast until we measure it.
So if I understand correctly, you capture certain characteristic of request and recognize following requests with like slow characteristic, then put in the slow lane.
I don't understand the question. Can you maybe repeat it?
So it's like a kind of like some kind of machine learning, or like how do you recognize future? Do you use some kind of like a certain property or certain feature to recognize the one?
It's execution time, right? So we measure the execution time. So we are the last step before the database, we know exactly how much it took to execute the query in the database plus the network, right? So the full round trip to the database. That's what we use as a measurement. We don't use any AI, anything heavy. It's very cheap. It's a very simplistic averaging. It's a rolling average, and we we created this simple method that you have an O on one for space and time. So it's very cheap to calculate, very cheap to keep in memory. Like, because it's not our goal here to, like you mentioned, machine learning. To do some machine learning, it will be possible with OJP. We emit metrics through Prometheus, but it should be done outside, right? Like, our job is not to do a deep evaluation into the intrinsic characteristics of the performance of queries, right? But we do want to know if they're fast or slow. So we created a very cheap mechanism of knowing if they're fast or slow. So we can put them in the right lanes. So that's the job we do. We don't do anything heavier in purpose, because the work we want to do is work related to transactional or to performing more and more reliably the statements that the application want to perform against the database. But I see where you're coming from. There are tools that can do that for you, that can gather these metrics in relation, especially to error rates and response time averages, and then do a deeper evaluation using machine learning or things like that, like AppDynamics or Datadog. They're very good at doing these things.
Anyone else? Questions? No?
No, no.
Oh, yeah, sure. No, please, this is great. Yeah.
Right, yeah, so like is there any scenario where OJP maybe not the good choice?
Oh, wow, that's a deep question.
That's a first. Like usually I don't get this question. Yeah, I think I mentioned during the presentation, if your app is a small app and that doesn't have a lot of load, I think OJP is not a good choice, right? Like you need to understand that even though we took a lot of care to make it very easy to integrate, even though the demo didn't show it, but it's very easy to integrate, right? And very easy to maintain. For example, our cluster mechanism that is coming out now, you don't need to have a consensus between the nodes in the cluster, because we developed a client relay way to know the health of the cluster. So the client, the JDBC driver, sends the health to the cluster, and so that's how the nodes know how many nodes are in the cluster, which ones are healthy or not. But even though we make it very easy for ops and for development, there is a cost there, right? So I think the evaluation you need to do is like, how big is the application you're developing? And I think for experimentation, sure thing, you should use OJP. But in relation to, let's say you're developing an app for your school or for a project that doesn't demand a lot of load, that will never have that much load, that's a case I would say OJP is not a good choice.
Makes sense. Yeah. Thank you.
All right, anybody else? Anybody? So Rogério, I wanted to mention, I can relate to, having demos go, not work too well. I gave a webinar at Payara about a year and a half ago. And it turned out that I was low on disk space, and all my demos just wouldn't run. It was, so I don't think they ever advertised the link for it at the time. But I did redeem myself with that earlier this year. I gave a sort of more of an updated, same talk, but with updated stuff on there. So anyway, I can relate. I totally understand. So
there's always a first, isn't it?
Yeah. So. But yeah, no, I look forward to trying it and, carving out some time and, taking a look. But it's getting on 1 a.m. over there by you, right?
Yeah,
So
nearly.
We'll let you go to bed. Just a note, we'll be out in London, my wife and I, in mid-March. So we're going to try to get over to Dublin afterwards. So it would be great to maybe get together for a little bit. So when I'm out there.
That would be nice. Yeah, that would be great. Please keep me posted. And thanks again for the opportunity to present to you guys. Thanks for the questions. Very good questions. you can only see like how much the audience is engaged by the questions, right? Like
Yeah, absolutely,
really,
absolutely.
really,
Got
really
a,
good
got a,
questions there.
got a great bunch of members that come. A lot of them are regulars. You know, we generally have students here too because we're at a university, but this is finals going on right now, so we don't have too many students at the moment. But yeah, Rogério, thank you again. I'm going to wrap things up here with my second set of slides. For at the end. I did fix the slides that have your name written out. So,
Very good.
but yeah, so thanks again. We'll definitely keep in touch.
Thank you guys, appreciate it.
Yes, thank you.
Bye bye.
Okay.